Hi, I'm Sean again, and this is Minute Math, and today we're learning about evaluating limits.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the limit as x approaches a -3 from the right, of x plus 2 over x squared plus 5x plus 6, and we're also given this graph. Now, the graph makes it a little easier to visualize what happens as x approaches -3 from the right. But let's go break it down algebraically and we'll see how the two compare. Well, this right here, I can see, well, the bottom part can factor. So we take the limit here as x approaches a -3 from the right, and we have an x plus 2 in the numerator. The denominator will factor to be an x plus 3 times an x plus 2. Notice that the x plus 2's will cancel. And so this limit, again, the limit as x approaches -3 from the right, can be written as 1 over x plus 3. Now we know we can't take or just plug directly in -3 in for x. We'll be dividing by 0 here, clearly. And that's seen with the asymptote there on our graph. But how can we interpret what we see in the graph versus finding it algebraically here? Well, we look at this -3, right, and we're approaching it from the right. So I like to pick a value, right, just to the right of -3 and see if this denominator is, well, positive or negative. We know the denominator is approaching, well, 0, which 1 over 0 kind of gives us that asymptote to a positive infinity or negative infinity. So right here, I'm going to say, what happens if I put, let's say, a negative, this is not really equal to, so I'm going to do this, not really equal to, but we take that 1 over, and instead of x being -3, let's try a -2.9 plus 3. All right, when I put that into our little x value, this denominator is equal to, well, a positive really number. That's really what I'm looking for. It's going to be positive still in the denominator as it gets closer and closer to 0. What does that tell us? That tells us that we're actually approaching a positive infinity when we approach -3 from the right. So we have positive infinity right here. And so we can see in the graph here, as we approach -3 from the right, we're going to a positive infinity. And so our limit here and the final answer is a positive infinity. We're given this limit right here, the limit as x approaches a -4 of x squared over 4x plus 16. And we need to evaluate this limit. Now we're given a graph of this limit, which really helps us determine what's happening here at -4. Sometimes we like to break this down and see if this thing simplifies a little bit to get a better idea. So if we do that, we take the limit as x approaches -4, x squared stays up top, and I pull out a 4 in the denominator. And we have 4 times an x plus 4. And we can clearly see now, we put a -4 in for x, our denominator will equal 0, and we can't directly substitute -4 in to find this limit. Now the graph that's provided here shows what happens at -4. At -4 we have, well, if we could approach -4 from the right, we're going to positive infinity. If we're approaching -4 from the left, the limit goes down to negative infinity. And we're asked to, what happens, well, we're asked here, what happens at -4? So we have to bring both of them together, but they're not equal. So if the left and the right are not equal, we would say that this limit does not exist. And so for this limit, our final answer is it does not exist. We're given this limit right here, the limit as x approaches a -2 from the right of 3x over x plus 2. And we need to evaluate this limit. Now it's tricky here, we can see our graph, but what's tricky is at -2, we can't just plug it into x, right? That makes the denominator equal to 0. So what I like to do is try to see, well, what happens as we approach -2 from the right? And we really want to see, is this going to be a positive or negative, okay? Since we're dividing by a 0, that almost, or it's approaching a 0, dividing by a 0, we know it's going to go to some infinity. Either it's negative or positive, and that's what we're trying to figure out here. Well, if we approach -2 from the right, a value just to the right of that would be a -1.9. So what happens if we take the 3x and x plus 2 and put a -1.9 in? So 3 -1.9 in over -1.9 plus 2. Now, what I'm really looking for here is I know this denominator is approaching 0 as we get closer to negative 2. And that's going to cause the infinity here. So I'm not really actually trying to evaluate what these values are, just if they're positive or negative. So the numerator is clearly going to be a negative. Negative 1.9 times 3 is a negative number. The denominator is going to be a small number, but it's still positive. So what happens when we have a negative over a positive number? It's going to be a negative. And so we would say that this limit is approaching negative infinity. And we can see that in our graph. Look at negative 2, right? X value being negative 2 right there. And as we approach that from the left, from the right, from the right, it's going down to negative infinity, okay? So our final answer here is a negative infinity. We're given this limit right here. The limit as x approaches a negative 1 from the right of x squared over an x plus 1. And we need to evaluate this limit. Now, we have our graph here. We can use the graph to kind of solve this pretty quickly. But I want to see if we can do it algebraically and compare it with the graph here to get a good visual. What I like to do here is first I notice negative 1 I can't plug in directly. We're dividing by 0. And that tells us we're having a limit that's going to some infinity, whether it's positive or negative, or maybe doesn't exist. So here we're approaching negative 1 from the right. Okay, we're approaching negative 1 from the right here. And so what I like to do is take a value that's just to the right of negative 1 and see what happens if it's positive or negative. And we'll see that in a moment. So we take the x squared, I'll put, let's say, a negative 0.9 squared. And it's going to be over a negative 0.9 plus 1. Plus 1. So again, negative 0.9 is just to the right of negative 1. And we know this limit, again, divided by negative 1 makes it go to infinity. We just don't know if it's positive or negative. Here, I don't really care what the actual value is. I just want to see if it's positive or negative. So negative 0.9 squared is positive. Negative 0.9 plus 1 is going to be a positive number. Positive. So since we have a positive over a positive, we would say that this limit is approaching a positive infinity. And we can see that again in our graph. As we approach negative 1 from the right, our graph goes up to positive infinity. So again, our final answer here for this limit is positive infinity. We're given this problem right here. The limit as x approaches a negative 3 from the left of 2x over x plus 3. And we have to find the limit here. So there's a few ways to kind of go about this. We can use a table, and we can type in or put in some values that approach negative 3 from the left. So if we did that, we have x over y, and let's put in values that approach negative 3 from the left. If we put negative 4 in, we would get an 8. If we put a negative 3.5 in for x, we get a 14. And a negative 3.01 in for x, we get a 602. Those are pretty large values as we get closer and closer to negative 3, and we're approaching from the left-hand side. And we can see that this limit is going to be probably approaching infinity. But why? Well, when we're dividing here by what's going to be approaching a 0, right? As negative 3 goes in for x, we're dividing by 0. So if we approach from the left, really what happens here? And I like to do this little exercise. I pick a value just to the left of negative 3, negative 3.1, and plug that in for x, negative 3.1 here. And I have negative 3.1 plus 3. And all I'm caring about here is, well, we know it's going to go to infinity, but is it positive or negative? And I'm caring about is the final result positive or negative? Well, the numerator, 2 times positive times a negative is a negative. Negative 3.1 plus a 3 comes out to still be a negative value. And a negative divided by a negative is a positive. So from our table and from our knowledge about limits here, as we approach, right, negative 3 when we're dividing by like a 0, we would say that this limit is equal to a positive infinity, and that is our final answer. We're given this limit right here. The limit as x approaches a negative 2 from the right of 1 over x squared minus 4, and we have to evaluate this limit. Now, what's tricky here about this limit is, well, we only have a 1 in the numerator, and we're dividing by some expression that can be factored. So let's go factor that to get a better idea of what's going on here. So the limit here, as x approaches -2 from the right, of 1 over, and the denominator factors to be an x minus 2 and an x plus 2. And notice if we plug -2 in for x directly, we'll be dividing by a 0, and we don't like that, okay? So with that happening, we don't like that, we have to take what we know about limits here and try to understand what's going on here. Now I want to make a little table here. We have x and y, and I'm going to put in some values to see what happens as we approach -2 from the right. If -1 goes in for x, our output's a -1/3. If a -1.5 goes in for x, we get a -0.571, and of course I broke rules of fractions and decimals, but it's okay. A -1.99, we get a -25.06, and I use my calculator for these values. And a -1.999, we get a -250.1, and that's approximately. And what that shows us is as we get close to -2 from the right, we're approaching a negative infinity here, right? It's getting larger and larger, approaching negative infinity, which makes sense. We're putting in here a dividing by some 0, we know that's going to happen. Now, how can we also determine that without the table? Well, if we're dividing by a 0, we know it goes to some infinity, positive or negative. So we need to figure out if it's a positive or negative leading up to that infinity. So what I like to do is take a value just to the right of -2 and plug it in. We have 1 over well, let's go -1.9 is just to the right of -2, minus 2, and -1.9 plus 2 right here. So I plugged it in for both of those. And what happens? I'm only looking for, is this final result positive or negative? So the top number 1 is a positive. Here, -1.9 minus 2 we know is a negative number, and we're going to multiply that by, well, -1.9 plus 2 is a positive number. Negative times a positive is a negative. So we have positive over a negative here. And a positive divided by a negative, again, is a negative. And that tells us we're going to approach negative infinity here. So our final answer here for this limit is negative infinity. We're given this limit right here. The limit as x approaches 3 from the left of a negative 4x over x minus 3. And again, we're evaluating this limit. I like to first use a table here to get some basic points, and then we'll understand how to do it more conceptually. If I approach 3 from the left, I like to plug in values to see where this table's approaching. If I put a 2 in for x, my output is an 8. If I put a 2.5 in for x, my output becomes a 20, and for that equation here, and a 2.9 goes in and it's a 116. So from the table's point of view, we're approaching a positive infinity. But how can we understand this conceptually? Well, we know if we put in 3 directly, we're dividing by 0. Okay, and we're dividing by 0, that's generally a clue that it's approaching some infinity here. So if we're approaching from the left, I like to pick a value here that's just to the left of 3 and see what happens with if this is positive or negative overall result. So we have a negative and we have 4. I'm going to pick a value just to the left of 3 and say it's 2.9 over a 2.9 minus 3. Like so. Now I don't actually care what the value is, we found it here, it's 116, but really I'm looking for is it positive or negative. The numerator, positive times a positive is a positive, and we have the negative up there, so the numerator is a negative here. The denominator, 2.9 minus 3, is a negative number. A negative divided by a negative is a positive. And so this limit approaches, right? As we approach 3 from the left, it goes to a positive infinity, and that is our final answer. We're given this limit right here, the limit as x approaches 1 of a negative 3 over x minus 1, and we need to evaluate this limit. Now with something like this, notice we're not approaching 1 from the left or the right, from both left and the right. So let's use a table here to see what happens. Now I've calculated these values ahead of time for you. If we plug 0 in for x, and we're going to approach 1 from the left here, we put some values as we get closer to 1 from the left. 0 in for x, we get a positive 3. If we put a 0.5 in for x, we get a 6. And if we put a 0.9 in for x, we get a 30. So from the left-hand side, it looks like we're approaching a positive infinity right here. And it's getting larger and larger as we get closer and closer to 1 from the left. But what about from the right? Put 2 in for x, we get a negative 3. We put a 1.5 in for x, we get a negative 6. And a 1.1 in for x, we get a negative 30. And so if we approach 1 from the right here, as we get closer and closer to 1, we're going towards a negative infinity. So what does that tell us? It tells us that if we approach from the left, it's a different limit than approaching from the right. And so when that happens at a specific value, we would say that this limit does not exist, because it has to, at this point, equal or be the same from the left and the right. So our final answer here is this limit does not exist. We're given this limit right here. The limit as x approaches negative 2 from the left of an x plus 2 over an x squared plus x minus 2, and we have to evaluate this limit. Now, one of the first things I notice here is I'm going to try to factor out this denominator, see if something happens here. So we take the limit as x approaches a negative 2 from the left. We have an x plus 2 in the numerator, but the denominator factors out to be an x plus 2 times an x minus 1. And so it's a little easier to see that these x plus 2's cancel, and really here, the limit here, as x approaches a negative 2 from the left, is really just of 1 over an x minus 1. Now we know it doesn't exist right at negative 2, right? From here we could see, plug that in, we're divided by 0, can't do that. But with this simplification here, it kind of makes it a little easier for us. We can directly plug it in. This is what we call a distractor. And initially we would try and say, okay, we're going towards, we're divided by 0, so it has to be some infinity. But when that simplifies out, we don't have that anymore. It's a distractor. And so we actually can directly plug it in now, and we know what it's approaching. We know it can't equal at negative 2, but we can see what it's actually approaching. So I'm going to plug negative 2 in for x here. We have a 1 over negative 2 minus 1. And what happens here? Well, 1 over negative 2 minus 1 is, well, 1 over negative 3, or a negative 1/3. And we actually can see that with a table here. So I'm making a little table here, and I've calculated some values for you. And we're going to see what happens if we approach negative 2 from the left. I'm going to put some values in, and we'll approach negative 2 from the left here. Negative 3 goes in, we get a negative 0.25. A negative 2.5 in for x, we get a negative 0.2857. Negative 2.1 in for x, a negative 0.3226, and these are all approximate. And then negative 2 point, how many zeros? 1, 2, 3, 1, I tried. And we get a negative 0.3333. And we can see as we get closer to negative 2 from the left side, we're really approaching negative 1/3. And we saw that there. And so this limit here is a negative 1/3. And that is our final answer. We're given this limit right here. The limit as x approaches negative 3 from the left of a negative 2 over x plus 3. And we have to evaluate this limit. So we know at negative 3, we plug that right in for x, and well, we're dividing by 0. Can't do that. But when we divide by some 0 with a rational function, we know it's going to approach some infinity. So let's use a table, and then I'll show you some algebraic tricks to understand it better. So if you use a table here, I've calculated some values for you. We're going to approach negative 3 from the left. So I plug negative 4 in, I got a positive 2. A negative 3.5 in for x, I got a positive 4. A negative 3.1 in for x, I got a positive 20. And negative 3.01 in for x, and we get 200. And it looks like it's growing to infinity, but let's double check this. If I plug in a value that's just to the left of negative 3, I'm going to look if this is overall a positive or a negative. So I put a negative out here, and we have a negative 2 up top, right, or 2. And I'm going to put a value just to the left of negative 3, which is a negative 3.1, and for our x value. And now what I'm looking for is, well, is our overall result positive or negative? We have a negative times a positive number, so our numerator turns out to be a negative. Our denominator, negative 3.1 plus a positive 3, is still a negative. A negative divided by a negative comes out to be a positive. And so with that, with our table here, we can say that this limit is going to, when x approaches negative 3 from the left, a positive infinity, and that is our final answer. We're given this limit right here. The limit as x approaches pi over 4 from the left of 2 times the secant of 2x. And we're going to evaluate this limit. Now let's use a table here. We have our x and our y value right there. And we're going to see what happens as we approach pi over 4 from the left, as we get closer and closer to pi over 4. So I used my calculator and I plugged in, well, pi over 10. And then these are all rounded values here, but approximately 2.4721. I'm keep getting closer and closer to pi over 4. Pi over 7 came out to be a 3.2078 approximately. A pi over a 4.1 right here. Pi over a 4.1, getting closer to 4. I know fractions and decimals, but it's okay. I got 52.216. And what about pi over a 4.01? And I got a 510.57, again, rounded. So what happens as we approach 4 from the left here when we're plugging in for x? We notice that our graph is going, or equation in a sense, is going to positive infinity there. And so the limit here of our function of 2 secant of 2x as x approaches pi over 4 from the left is a positive infinity, and that is our final answer. We're given this limit right here. The limit as x approaches 3 pi over 4 from the right of 2 times the tangent of 2x, and we have to evaluate this limit. Now I like to use a table here, and I've calculated some values, and they're approximate, they're all going to be rounded here. Now I want to see what happens if we approach 3 pi over 4 from the right of our function here. So to approach from the right, I'm going to do a 3.1 pi over 4. Again, I know decimals and fractions don't really mix, it's not proper, but it helps us here understand what's going on as we get closer and closer to the 3 pi over 4 from the right hand side. So to do that, when I plug that in, we got a negative approximately 12.63. Well, what happens at a 3.01 pi over 4? We get a negative 127.3. And let's keep on going, 3.001 pi over 4. And again, that's an approximate value of negative 1,273, and that's a rounded approximate. So what happens as we approach this function from, as x approaches 3 pi over 4 from the right-hand side? We can see that this limit here, what's approaching, is a negative infinity, using our table here. So our final answer for this limit is negative infinity. We're given this critical thinking question. Give an example of a right-sided limit that goes to infinity as x goes to 5. So we know x has to go to 5, right? So we have a limit as x approaches 5, and it has to be a right-sided limit, so it's approaching from the right there. Okay, well, let's make it simple. If it's going to infinity, we're dividing by, in a sense, a 0. So divided by, we're going to put some x down here. Now, if it's approaching 5 from the right, if we're approaching from the right, we want this, approaching from the right and we want to go to positive infinity, we want this denominator to always basically be positive for values to the right of 5. So if I put an x minus 5 right here, our denominator, when we plug 0 in for x, will become, 5 in for x will become 0. Great, going to some infinity. But notice the values just to the right of 5 will make it positive, right? So if we test that out, if I pick a 5.1, we have 5.1 right here minus a 5. Well, is this positive in the numerator? Yes. Denominator will be positive. Positive over positive is a positive. Now we can test this with a table here. What happens if we approach 5 from the right of this equation here? 6 becomes a 1. 5.5 simplifies to be a 2. 5.1 becomes a 10. I've calculated these values for you. And 5.01 goes to 100. And so we can say that this limit right here is going to positive infinity. And so an example of a right-sided limit that goes to positive infinity as x goes to 5 is a limit as x approaches 5 from the right of 1 over x minus 5, and again, equals positive infinity. And there we have this part right here would be our final answer. We're given this critical thinking question. Give an example of a left-sided limit that goes to infinity as x goes to 5. Well, like before, we can take the limit here as x approaches 5, but it has to be a left-sided limit, so we approach from the left here. Now let's start with the same limit as the other one. We have 1 over an x minus 5. Now what happens when we approach from the left here though? Well, we know we're dividing by a 0, so it's going to some infinity there. But if we pick a value just to the left of 5, let's say 4.9, what happens? Well, we have 1 over a 4.9 minus 5. In regards to positive and negative, the numerator is positive here, and our denominator actually comes out to be a negative. A positive divided by a negative is a negative, and we want to go positive infinity. So if I just toss on a negative out front here, what happens? Well, the negative goes out here. We have a negative times a positive in the numerator, right? Divided by a negative, which is a negative over a negative, which is a positive. So let's go see this with a table here. I've created a little table with some test values with this function here. And what happens when we plug in different values as we approach 5 from the left. Plug a 4 in, we get a 1. Plug a 4.5 in, we get a 2. Plug a 4.9 in, we get a 10. And plug a 4.99, we get a positive 100. And so we can see with our table here and with our knowledge of our limits that are rational functions that we're approaching a positive infinity now. And so we have now created a limit here, as our final answer, of an example of a left-sided limit that goes to infinity as x goes to 5 is the limit as x approaches 5 from the left of a negative 1 divided by x minus 5. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.